It's honestly so obvious that you could have invented it yourself. But what's so special about this number? Why does it keep appearing in completely different fields like finance, biology, physics, probability, and even complex numbers? Its value is approximately 2.718281828, and it goes on forever. Now, instead of memorizing it, let's build it. Imagine you put 100 rupees in a bank that gives you 100% interest per year. After 1 year, you simply double your money. 100 becomes 200. Now suppose the bank adds interest twice per year instead of once. So instead of 100% once, you get 50% every 6 months. After the first 6 months, 100 becomes 150. After the next 6 months, you earn 50% on 150. So you multiply 100 by 1 plus 1 divided by 2 and then square the whole thing. That gives you 225. Already more than 200. Now imagine interest is added 4 times per year. You multiply 100 by 1 plus 1 divided by 4 and raise that to the 4th power. You get about 244.14. Now 12 times per year, you multiply 100 by 1 plus 1 divided by 12 raised to the 12th power. That gives about 261.30. Now every single day. You multiply 100 by 1 plus 1 divided by 365 raised to the power of 365. That gives about 271.45. Notice something. The more frequently you add interest, the closer the answer gets to around 271.82. Now imagine interest is added infinitely many times per year. Mathematically, that means you take 1 plus 1 divided by n, raise it to the power n, and let n go to infinity. That limit equals e, which is approximately 2.7182818. So your 100 rupees becomes 100 multiplied by e, which equals about 271.82. That is the maximum possible natural growth under continuous compounding. That's not decoration. That's structure. Now let's move to calculus. Consider the function e raised to the power x. When you graph it, it's a smooth curve that increases faster and faster. Now here's the special part. If you take the derivative of e to the power x, you get e to the power x again. It copies itself. Now let's compare that with a general exponential function. Take a raised to the power x. If you differentiate that, you get a to the power x multiplied by the natural logarithm of a. There's always that extra factor. For the derivative to equal the original function, that extra factor must equal 1. So we set the natural log of a equal to 1. Solving that gives us a equals e. That means e is the only base where the exponential function equals its own rate of change. Now, let's apply this to something real. Suppose the rate at which something grows is proportional to how big it already is. In math language, that means the rate of change of y with respect to time equals k times y. To solve that, you separate variables. You divide both sides by y and multiply both sides by dt. Then you integrate. The integral of 1 over y with respect to y equals the integral of k with respect to time. That gives the natural logarithm of the absolute value of y equals k times t plus a constant. Now raise e to both sides. You get y equals a constant multiplied by e raised to k times t. So whenever growth rate depends on current size, the solution automatically becomes an exponential with base e. That's bacteria. That's population growth. That's radioactive decay. That's cooling. That's charging a capacitor. Nature doesn't insert e. It falls out of the math. Now let's define e in a completely different way. Take the function 1 divided by x. Graph it. It's a curve that decreases as x increases. Now calculate the area under that curve from 1 to some number. That area equals the natural logarithm of that number. Now here's the key definition. E is the number where the area under 1 over x from 1 to e equals exactly 1. Not approximately, exactly 1. So, if you draw the curve 1 divided by x, start at x equals 1, move right until the shaded area under the curve equals 1 square unit, the x value at that point is e. That means e is built directly from geometry. Not finance, not growth, pure area. That's why logarithms with base e are called natural logarithms, because they arise naturally from integration. Euler discovered that e raised to the power I times x equals cosine of x plus I times sine of x. That already connects exponentials and circles. Now plug in x equals pi. You get e raised to the power I times pi equals -1. Rearrange it. E raised to the power I pi plus 1 equals 0. That single equation connects 5 constants: 0, 1, pi, e, and I, the square root of -1, growth, circles, imaginary rotation, unity, nothingness, all tied together in one line, and it is mathematically precise. Now step back. We've built e from compound interest. We've seen it as the only function equal to its own derivative. We've defined it using area under 1 divided by x. We've connected it to complex numbers and rotations. Different fields, different starting points, same number. That's not coincidence. Whenever change is smooth, continuous, and proportional, e appears automatically. You don't choose it. The math forces it. So is it God's favorite number? Maybe that's dramatic. But if the universe runs on continuous change, then 2.718281828 is the number that keeps the system consistent. And once you understand that, you start seeing it everywhere. Thanks for watching. Don't forget to like, share, and subscribe if you want more deep dives like this.